Hi friends, the next topic is when two alternators are operating in parallel at loaded condition. Here, see two alternators operating in parallel with a load. I connected load to the parallel operation set. For example, machine 1 and machine 2. These two are operating in parallel, which the KVA rating and whose the KW rating and reactive power rating and power factor angle and power factor of machine 1, power factor of machine 2 are like this. Now, what is our topic? The first topic is that effect of excitation. When the prime mover input is maintaining constant, this is our first topic. So exactly, effect of excitation. Here actually we have E1 and E2. When excitation of machine 1 increases, I increased my machine 1 excitation, then this goes like this. This is E1 dash like this. Are you getting or not? Nothing but the circulating currents comes into picture. Here circulating currents comes into picture. I told you already, the circulating current is from first machine to the second machine. From first machine to the second machine. So here, when the circulating currents is flows from first machine to the second machine, the machine 1 is demagnetized and machine 2 is magnetized. And here the current of the machine 1, the current of the machine 1 is nothing but I1 plus JIR, or I active plus reactive. Actually, the current of the machine 2, I active plus reactive. This is actually the current of the machine 1 and machine 2. But when excitation of the machine 1 increases, again this delivering extra current, some extra current. What is that? Plus JIC. Here this is delivered, but this is subtracted to the machine 2. Nothing but this is minus JIC. This is plus JIC, this is minus JIC. Nothing but what here is increases, the reactive component is increases. What here is decreases, the reactive component is decreases. When the reactive component increases, what happened to active component? The active component of the first machine is constant. And here the reactive power component decreases. What about the active component? The active component of the machine 2 also maintaining it constant. Here the changes are only reactive components, because here the circulating currents is a reactive component. Exactly, the active powers of machine 1 constant and active power of machine 2 also constant, but the reactive power of machine 1 increases. See here, reactive power of machine 1 increases and the reactive power of machine 2 decreases. We know the apparent power is equals to square root of active power square plus reactive power square. Are you okay? So, when the reactive power increases, by maintaining active power constant, what happened to apparent power? Apparent power also increases. When the active power maintaining constant, if the reactive power decreases, what happened to apparent power? Apparent power also decreases. The kVA rating of the machine 2 decreases, kVA rating of the machine 1 increases, because of course the kWs are constant, but the reactive powers are changes here. Here reactive power increases, so ultimately total power increases. Here reactive power decreases, ultimately total power decreases. Then in generally the active power is constant, but here the reactive component increases, nothing but what happened to power factor? If the reactive component increases, the power factor decreases, we know that. As well as if the reactive component decreases, what happened to power factor? The power factor increases ultimately. So tell me, what happened to power factor of the machine 1? The machine 1 power factor decreases and the machine 2 power factor increases. Depends on reactive component. When the power factor decreasing, nothing but its power factor angle is increasing. When the power factor is increasing, nothing but its angle is decreasing. When angle decreases, power factor increases. This is generally the analysis of loaded condition parallel operation, excitation increases. Very important concept is this. So this is generally from this current equation I given all the data for machine 1 and machine 2. Another we have a trick also for easy understanding. We have another trick. For example, I am taking for machine 1. Is it okay? Is it clear? Okay. So for this machine 1, I am drawing for machine 1. For example, this is my KW and this is my kVAR and this is my kVA. Of course, this is the power factor angle, you know that, phi 1. This is actually the machine 1. But when excitation of machine 1 increases, excitation increases, nothing but the kVAR increases. kVAR increases to this much. This is the new kVAR increment. What about kW? kW is constant, I said you already. If the disturbance from excitation, the active power is constant but reactive power changes. Here the reactive power changes. What happened to kVA? kVA also increases. This is kVAR. kVAR increases and kVA also increases. kVAR increases, I said you already. kVA increases, I said you already. kW constant, I given you already. What about power factor angle? Once see, this is the power factor angle. the power factor angle also increases. I said you already. If the power factor angle increases, what happened to power factor? Ultimately, the power factor decreases. This is simply about the machine 1. If the same diagram for machine 2, when we draw the same diagram for machine 2, see, actually this is my KW and actually this is my KVAR 2. Actually this is my KVA 2. Actually this is my power factor angle phi 2. But what happened when here machine 1 excitation increases, when its reactive power increasing, nothing but its reactive power is not same, it is decreases. This is the KVAR 2 dash, which is decreases. What happened to KVA? KVA also decreases. What happens are here? The KVAR decreases and KVA decreases. What about power of active power? Active power maintaining constant. What happened to power factor angle? Once observe here, power factor angle also decreases. If the power factor angle decreases, then the power factor increases ultimately. This is the effect of excitation at loaded condition. I given you two models. You can analyze as your own, whatever it may be. Are you okay? Getting or not? Right? The next topic is effect of the topic B. Effect of prime mover input when excitation constant. This is the second concept at loaded condition. You have to do this one. Hold the video and do this one. Come on, do it fast. Effect of prime mover input changes. Come on, do fast. Hold the video and do it fast. Right? See here, again here two machines are operating in parallel, machine 1 and machine 2. Exactly. Here what happened? Machine 1 KVA rating KVA and KW and KVAR, power factor, angle and power factor. And machine 2 KVA 2, KW 2, KVAR 2, phi 2 and power factor. This is the machine 1 and machine 2. When prime mover input of machine 1 increases, here I increased prime mover input of machine 1. Then again the current increases. But the current is not in reactive component. The current is in active component. Because in phase, not in 90 degrees. Of course, this is flows from first machine to the second machine. Actually, the first machine current is active component plus reactive component. The second one is active component plus reactive component. But when the prime mover input of machine 1 increases, then the active component is added here. This is not the reactive component. This is active component of circulating current. And here that active component of circulating current is subtracted from the machine 2. Nothing but observe here, there is no changes in reactive components. Nothing but here reactive powers are constant. here reactive powers are constant for machine 1 and machine 2. But here active component of machine 1 increases and active component of machine 2 subtracted. What happened? The reactive powers maintaining it constant. There is no change. I said you already, if the disturbance is from prime mover side, then the reactive powers are no change. Nothing will change in reactive powers. But what happened? Of course, the reactive powers are constant, but the active power of the machine 1 increases and the active power of the machine 2 decreases. Ultimately, we know the apparent power is equals to active power square plus reactive power square. When the reactive power maintaining constant, if the active power increases, kVA rating increases. If the active power decreases, kVA rating decreases. As well as when the reactive power is constant, if the active component increases, then power factor also increases. If the active component decreases, then power factor also decreases. Active components are power factor is directly proportional to active components. Power factor is inversely proportional to reactive components. Here active component increases, power factor increases. Here active component decreases, reactive power factor decreases. So what happened here? Here the power factor increases and here the power factor decreases. When the power factor increases, if the power factor angle decreases, then power factor increases. When the power factor decreases, if the power factor angle increases, then power factor decreases. This is analysis based on the current values. And I given you trick also. How? Let's draw for machine 2. You have to draw for machine 1. I will draw for machine 2. So listen, for example, this is for machine 2. This is my KW2 and this is my KVAR2 and this is my KVA2 as well as power factor angle 2. When prime mover input of the machine 1 increases, the active component of the machine 2 decreases. Nothing but from here it is decreased up to this. This is the active component of machine 2. Nothing but here is our reactive component. These two should be same. These two should be same. So there is no change in reactive component. Active component decreases. Then what happened to kVA apparent? See, the magnitude of kVA decreases. Of course, the magnitude of kVA decreases. What happened to power factor angle? The power factor angle is increases. Then the power factor ultimately decreases. This is for machine 2. Now you have to draw for machine 1. Hold the video and draw the diagram for machine 1. Check is these values are correct or not. Okay? Are you doing or not? You come on, do ma. Right, do it. So, okay, completed? See here. So, this is the KW1 and this is the KVAR1 and this is the KVA1. Of course, this is the power factor angle 1. When the prime mover input of the machine 1 increases, then the KW also increases. Kw also increases from Kw1 to Kw1 dash. And the reactive power, no changes. This is the reactive power, there is no change in magnitude. There is no change in magnitude of reactive power. Reactive powers are same. But what happened to active component? Active component increases, reactive component same. Then what happened to kVA? See here, the magnitude of kVA increases. When the magnitude of kVA increases, what happened to power factor angle? The power factor angle is decreased now. Yes or no? Are you getting or not? The power factor angle is decreases. When the power factor angle decreases, ultimately power factor increases. This is the question on effect of prime mover input. Very, very, very important one. I given in this video two topics. One is effect of excitation and other one is effect of prime mover input. In those case, the excitation maintaining constant. In that case, the prime mover input maintaining constant. And here the simple way, actually we know that if the disturbance is from excitation side, active component constant, reactive component changes. If the disturbance is from prime mover side, reactive component constant, active power changes. Based on that, what happened to power factor is the question. So we analyzed what happened to power factor. Are you okay? Right? Are you happy? Thank you.